All right, I'm going to go ahead and do lesson 9.1 notes. And we started with a launch, which is reviewing some vocabulary. So we'll start with that. We have congruent circles. That would be F. And you'll notice they have the same radius. That's what makes them congruent. Concentric circles are circles that are similar. They have the same center point. So that'd be E. And the radius is, if you look at, it's going to be C, OE. A chord is a line segment with both endpoints on the circle. That's A. The diameter is D. A tangent is a line that hits the circle at exactly one point, and that would be B. The central angle is an angle with the vertex at the center of the circle. That is J. And the minor arc is an arc that's less than 180 degrees. That it is indicated with two letters. That would be G. Major arc is more than 180, indicated with three letters. That's I. And a semicircle is exactly 180 degrees or half a circle. That's H. Okay. So in the figure at right, central angle BOA determines the minor arc, AB. And angle BOA is said to intercept arc AB because the arc is within the angle. This arc is referred to as the intercepted arc. And the measure of a minor arc is defined as the measure of its central angle. So the measure of arc AB equals 40 degrees. So you'll notice that this central angle right here is 40 degrees. And it is the same as the measure of the arc it intercepts. So the measure of arc AB is equal to the measure of the central angle AOB, right? They both equal 40 degrees. Now, how are you going to find the measure of the major arc ACB? Well, that will be equal to 360 minus 40, which is equal to 320 degrees. So let's see. Let's go ahead and do the first example. At the figure at right, tangent TA and TG are both tangent to the circle. And if the major arc formed by the two tangents measures 220 degrees, find the measure of angle T. So we're trying to find the measure of this angle. And we know that this major arc right here is 220 degrees, which means that, I'll use blue here, the blue arc right here, that arc, well, what is that equal to? What's the measure of arc AG going to be? Well, that's going to be 360 minus 220, which equals 140 degrees. So the measure of the central angle ANG is also equal to 140 degrees. So this angle here is 140. Now in investigation 1, we found out that a tangent is perpendicular to the radius of a circle, making both of these angles 90 degrees. In addition, you'll notice that this shape right here is a kite or a quadrilateral. And by the quadrilateral sum conjecture, the angles are going to add to 360, which means that the measure of angle T will equal 360 minus 90 minus 90 minus 140, and that will equal 40 degrees. Now, as a side note, what kind of shape is this quadrilateral? Well, these are both radiuses, so they're the same. And in investigation 2, we found out that the distance from T to A is the same as the distance from T to G. So these are also congruent. So we have a kite. This is a kite. Okay. Some more vocabulary now. Tangent circles are two circles that are tangent to the same line at the same point. They can be internally tangent or externally tangent as shown. What conjectures can you make about tangent circles? You will explore more about them in the exercise set. So we have externally tangent circles and internally tangent circles. And you will use these vocabulary in some of the homework problems. Starting with this extra example. I'm going to find x. So to find x, we're going to use the fact that this major arc right here is 245 degrees, which means the minor arc is going to be what? Well, let's call this A, B. So the measure of arc AB is equal to 360 minus 245, which equals 115 degrees. And so what is, let's call this O, what's the measure of angle AOB equal to? That central angle will also be 115 degrees. So if you look at this triangle right here, this larger triangle, this is 35, this is 115, and this is x. And so x is going to equal 180 minus 115 minus 35, which is going to equal 30 degrees. So to review, you know the major arc is 245, and since an entire circle is 360, you just go 360 minus 245 to get 115. And since the measure of this arc right here is 115 degrees of arc AB, the measure of the central angle is also 115. What you're going to do next is you isolated this triangle right here and drew it to the right. And you know the angles of a triangle add to 180, so you can figure out that x is 30. Okay, so final question. Is triangle EGN congruent to triangle EAN? How do you know? Well, are they congruent? The answer is they are. You could either do side, 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 or side, angle, side. I'm going to do side, angle, side, because we know that these are the same, and then these angles are the same here. Okay, so first of all, I know AE is congruent to EG, since they're both radii. I know that angle E AN is congruent to angle EGN. And this is because of, in the packet I gave you, go to investigation 1, it's called the tangent conjecture. That says that both of them are perpendicular. So it says both of these angles are right angles, and a tangent of a circle is perpendicular to the radius drawn at the point of tangency. And we also know that AN, I'll leave some space here, AN is congruent to GN. And that's from investigation 2, tangent segments conjecture. Now this step right here, this middle step, if you were doing a formal proof, there'd be a few more steps there. But in this example, we'll just leave it at that for now. And so that means that triangle EGN is congruent to triangle EAN by side angle side. And so yes, in this chapter, we are going to be doing some more proofs. All right. So in your homework, you are also going to be doing some constructions of a tangent, and that's going to involve doing a perpendicular bisector. So go ahead and watch my homework videos, and I'll go over how to do that again. And that concludes lesson 9.1.